Hello, I'm going to talk about Newton's second law for rotation. Okay, so let's start it out with comparison of the translation and rotation. So this is the rotation, and this is the translation. So in terms of formula, second law, right? So second law. This one here is tau, which is torque, equal to I, which is moment of inertia, times alpha, which is angular acceleration. Okay, and this side here is F, force, M, mass, times linear acceleration. So the unit here, this is meter Newton. This is kg, meter square. And this is radian per second. So radian is essentially just 1. And this is Newton. And this is kg. And this is meter per second square. Sorry, there's a second square there. Okay. So this is unit. And we would, we talked about I already, we talked about alpha already. Now we're going to put it together, right? So just in terms of the driving, right? The driving, or like, the engine, right? Kind of like the engine here, right? This one here is the torque, right? The torque is driving it. And this one here is the force. So it's kind of, so they are two different units and they are two different kind of concept. But torque is based on force, right? So this is based on force, but it's not equal to force based on F, okay? And in terms of the motion, right, or the motions, accelerations, right, in terms of the motion, right, the motion here, meaning this one here is the angle, right, theta, okay, which is angle, right? And this one here is the x, which is the displacement. Okay. And of course, in terms of acceleration, this one here is angular acceleration, which is alpha. And this one here is a linear or translational, right? Linear acceleration, which is A. Okay. So that's just a comparison for the rotation and translation. But let's get back to the Newton's second law. So Newton's second law says tau is equal to I alpha, right? Right. So the tau here, right? The tau here, which we talk about, just give it to you again, is defined as a lever arm times force, and then times the sine theta, where the theta here is the angle between R and F, right? And this should be in the plane, right? In the plane of motion, in the plane of rotation. Okay, this theta here, the RF should be in the plane. Okay, if it's not in the plane, then this theta is harder to define. So this was from previous, and so now you can put this into here. Okay, so students often confused about this part here when you put this into here, so they're confused whether I should use this one or whether I should use this one. Okay, this one here is second law. But this here is just how you compute, right? How you compute tau, that's all, right? It's just the way of computing tau given R, F, and theta, okay? Right, now let's give an example. of Newton's second law, right? So let's talk about example. Example, right? So let's say if we have a disc, okay, like in the merry-go-round, and then you support it with a pivot, okay? We call this a pivot. Yeah. So pivot in this sense right here, it's kind of like the axle here, right? But the axle is, this is the axle, right? This is your axle, so, right? But pivot, it's more like something that's supported, right? And then that turns out to be coincide with the axle like that. Okay, so let's say we have the M of the disc, okay? This is merry-go-round. So this is a merry-go-round example. So we use a lot of this in rotation. So let's say M is equal to 1 kilogram. Let's say R here, right? R is equal to 1 meter, okay? And then we study the moment inertia. So in this case, the I for the disk, right? So different geometry, they are different. So it's equal to 1/2 mr squared, only for the disk, right? And also it's for this axis. If you shift the axis, then this formula has to change. This is 1/2 times 1 times 1 squared. So that's equal to 1/2. Okay, right. Let's say if I apply a force, right? So let's say your father apply a force on this side here, parallel to the plane, right? And then your mother apply a force to this side here, and they are the same force. F is equal to 1 Newton, and this F is also equal to 1 Newton, okay? So both of them will be helping you to rotate, right? Will be helping you to rotate kind of like that right now, right? So you will try to get an alpha, right? The alpha will be going this way, okay? Right. And so now let's compute the tau first. So this is compute the tau, we're computing. So we compute the tau, we use tau is equal to R F sine theta, right? And let's just say that this angle here, let me change in color here so it's a little more obvious. This angle here is still 90, okay? But they are in the plane, okay? This force is in the plane of disk. Because I'm drawing a 3D here, right? So it's in the plane, okay? In the plane of the disk. So it's not perpendicular, but it's in the plane, and then you have a 90-degree angle. This one too, okay? This one also. So then we're gonna call this one, 1, but they are the same, right? And this one 2. So then you have tau 1, which is F1, and you have R1 and R2, right? The R2 is the same as R1 here. R2 and R1, they are the same, but we're gonna call that in theta 1. So theta 1 is between R and F. This is theta 1 right there, okay? And this is theta 2 right there, right? So in this case, we make it, right? We set it to theta 1, theta 2, both are equal to 90 degrees. And look at this, right? They both are helping you in the same direction, right? If you change the F2 to the other direction, then they will cancel each other out, okay? So now we have torque 2 is equal to R2 F2 sine theta 2 also, right? So obviously the total torque, the total here in this case, is equal to tau 1 plus tau 2 because they are same direction. They both is going in the, if you're looking down, right? If you're looking down this way, they're going in the counterclockwise direction, right? CCW. So this is in this, both are in CCW. And this is also CCW. This is also CCW, right? So both are CCW, so you can add them together, right? So then there's an add because they both are CCW, counterclockwise. So then we have this one equal to 2 times of RF sine theta. But sine theta is nothing but 1, right? Because it's sine 90 degrees, so that's 1. That's equal to 2 times 1 times 1, right? That's equal to 2 meter Newton. All right, so we know our torque now, and we know our I now. This I is equal to kg meter squared. Okay, so now we can compute our alpha, right? So changing color here. Alpha. So alpha is equal to tau divided by I, right? So tau is equal to I alpha. So I'm just, rearrange, right? So I rearrange, right? Second law. right? Newton's second law, right? Newton's second law of rotation, right? Okay, Newton's second law of rotation. So that's equal to 2 meter Newton, right? Those are all SI units, and I is kg meter squared. So that's equal to 1/2. So it's going to be equal to 4, and that's radian per second squared, right? So then you have your alpha, all right? So we're going to stop there, and so hopefully you learning a little